Okay guys, lesson 3, calculating standard deviation. We're still in data here. We'll be on data for, a few weeks here. All right, so definition of standard deviation. From now on, I'll probably just say STDEV just to make it easier. Standard deviation is a measure of how spread out the data is. All right, so in other words, higher standard deviation means data is more spread out. It's more spread out. We might also say it's less consistent. It's not all the same. It's more like spread out. All right, so if you have a high standard deviation, it means you're all over the place. You're not very consistent. If you have a really low standard deviation, it means all your data is like tight together. You're very consistent. So you're a bowler. Low standard deviation means you're about the same every time. There's not much spread. High standard deviation bowler means, hey, they score 80, they score 150. They're all over the place. They're not consistent. So it's a way of measuring how consistent the data is. All right, so I'm going to give you a data set and calculate it out for you. It's just a bunch of steps, guys. So you just got to follow steps. It'll look a little scary, but once you did it a few times, it's pretty easy, kind of fun. Okay, so here's a data set that has 8 data points. Find the mean. Number 1, find the mean. Okay, so I'm going to use this symbol for mean. It's a mu. It's like a Greek U. It's just a general symbol for mean. 64 is the sum. I already added it up. Divided by 8, so our mean is just at 8. Okay, next step is list out your data. List the data. Okay, I'm going to call it X. Okay, I'm going to call the data X just as a variable. So I'm going to list it down here. Okay, list them all the way down. Next step is subtract the mean. Step 3. Subtract mu, which is the mean. Okay, so I'm going to say X minus mu. Okay, I'm going to take this number 2, which is my X, minus off the mean, which is 8. I'm going to take 4, I'm going to minus 8. 6 minus 8. Okay, I'm just going to minus 8 all the way down. So this is negative 6, negative 4, negative 2, negative 2. Now we're up to positive, right? 1, 10 minus 8, 2, 12 minus 8, 12 minus 8, 4, and 15 minus 8 is 7. I just took every single data point and minused off 8 because 8 was my mean. Next step, step 4, is square those. So I'm going to take my X minus mu, that answer, and just square it. So negative 6 squared is 36. Negative 4 squared, don't need to show you the work, I don't think. 16. Negative 2 squared is 4. Negative 2 squared is 4. 1 squared is 1. 2 squared is 4. 4 squared is 16. 7 squared is 49. Okay, so I squared all those answers. All right, now we're going to go down here. After we squared all those differences, we're going to add them all up. Okay, when I added these, I'm going to add some lines here, just make it a little more clear what I did. Okay, when I added these, I got 100. Okay, double check my math there, but I think it comes out to 100. So step number 5 is add them up. Add these. Okay, then the last step, it's kind of 2 steps in one. I'm going to divide by number of data points. Then square root. Okay, so in other words, I'm going to take that 100, divide by 8, I'm going to say divide by n. Okay, n is the number of data points, so it's 100 divided by 8. There's 8 data points, 1, 2, 3, 4, 5, 6, 7, 8 of them. And then you just do a square root on that. So 100 divided by 8. I didn't have that quite worked out. Give me 1 second. 100 divided by 8 is 12.5. And then I got to do a square root on that. Boom. I'm going to round to the nearest tenth, 3.5. Okay. So this is my standard deviation down here. Okay. This is the answer. So make sure you realize the thing I found here at the end after all those steps is the standard deviation. All right. I'm just going to do that one example since they take a while to do. You're going to have to do about 2 or 3 of these in your homework, but follow those same steps every time. All right. The other thing that will come up on your homework is there will be a scenario, and it will ask you to analyze it a little bit. So it'll say something like, if Jim has a standard deviation of 5 points, and Larry has a standard deviation of, say, 3 points, what do you know? Okay, I'll tell you what, you can't really tell who's the better, whatever this is, basketball player. Say, well, he's got higher. Well, higher's not necessarily better. All we know is, hey, Larry's is lower, so I'm just going to say Larry's scores are less spread out. Or, obviously, you could say the opposite of that. Jim's scores are more spread out. Who's better? You know, it's not really clear. I mean, you say, well, Larry's more consistent, but Jim might be a lot better. Maybe Jim scores like 20 points, then 25, and then 30. And he's got they're spread out by about 5, whereas Larry maybe scores like 6 points, and then 3 points, and then 9 points. So you just can't tell which one of these is actually better as far as who scores more points. All we know is this. Larry is less spread out. He's more consistent. Jim is more spread out. He's less consistent. Okay? Standard deviation tells you how spread out the data is. It's actually how far the numbers are from the middle or from the mean. Okay? So just as an added thing here, if you want a little more detail, this is saying, hey, all the numbers are about 3.5 from the mean. Okay? So if I said, hey, the mean's at 8, how far are these numbers from 8? Well, they're all spread out differently, but kind of on average, the average distance from the mean is about 3.5. That's what this is telling you. How far are the numbers from the mean? If the numbers are very close to the mean, this will be very low. If your standard deviation is 0, it means all your numbers are exactly the same. There's no spread. Okay, we'll leave it at that.